let's look at notes for 7.3, volume by shell, the shell method. Uh, so far, we've learned the disk method and the washer method for finding volume, and this is an alternative for rather than using the especially the washer method. Um, on the AP exam, you're not going to require to have to use the shell method, but in some cases, the shell method can be more elegant and more simple than using the disk or the washer method. All right, so shell method is an alternative method for finding volume of a solid of revolution. The method is called the shell method because it uses cylindrical shells to evaluate the volume of a rotation. Okay, so the shell method, to find the volume of a solid of revolution, we use one of the following. If it's a horizontal axis of revolution, so let's say this blue line represents the axis of revolution, then we're going to be using horizontal rectangles. Okay, if it's a vertical axis of revolution, then we're going to be using vertical rectangles. Now the formula is 2 pi integral p of y h of y dy. So in these within this formula, it takes into account these cylindrical shells that are wrapping itself around the axis of revolution to create the solid. Note that the representative rectangles are now parallel to the axis of revolution rather than perpendicular. Okay, so this is the opposite to the disk and washer method. So just to kind of recall, when we're doing disk method or washer method, if our axis of revolution was horizontal, then we always made our rectangles, our representative rectangles, perpendicular, right? Now with the shell method, we're always now going to be parallel to the axis of revolution. Okay, we're going to be, in a sense, kind of layering or wrapping ourselves around the axis of revolution in a different manner. All right, so with the disk method, we thought of it as these cylindrical disks that are kind of stacking on top of one another. But with the shell method, imagine now we have these cylindrical shells that are now layering from the axis of revolution, and then kind of getting larger and larger, further and further away from the axis. So rather than stacking these cylindrical disks, we're now kind of wrapping these cylindrical shells around the center. So this is a visual representation of how a shell method develops a solid different from the disk or the washer method. Okay, let's look at example 1. Find the volume of the solid formed by revolving y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis. Okay, and so let's see if we can, so if we draw the graph, here's our y-axis, and we can indicate that this is going to be the axis of revolution. We also want to figure out where the shaded region is going to be. So bounded by y equals x squared plus 1, it's kind of a half parabola. X equals 0, that's the y-axis, and x equals 1, and the y-axis. Okay, y-axis, x equals 0. It should also say the x-axis. So x equals 0, this should be the x-axis. Okay, so that gives us this shaded region here, this enclosed shaded region here. Now here's our axis of revolution is vertical, so that means our representative rectangle is also going to be vertical. And now we can think about how we would, whenever we see a vertical rectangle, then we do top minus bottom. Everything is going to be in terms of x. So in that sense, we're going to be approaching the formula the same way. So everything has to be in terms of x. We're now dealing in terms of horizontal axis of revolution. So horizontal axis of revolution, we're going to follow this formula here. So 2 pi integral. Our values have to be in terms of x. So if we look at our shaded region, the furthest left of shaded region is going to be is x equals 0. The furthest right is x equals 1. X is the representative radius. And then our next value here, that was the shell radius. And then the shell height is now given by x squared plus 1, because x squared plus 1 represents all the potential heights for all these cylinders. So now we just work this through, distribute the x, we get x cubed plus x, 2 pi on the outside, so we go through, we can find the integral using power rule, x to the 4th over 4 plus x squared over 2. Evaluate the upper and lower bounds, and then finally we distribute the 2 pi through, and 2 pi times 3/4 gives us 3 pi over 2. And that is the volume of the solid for this shape using shell method. Okay, let's go to the back page. Okay, example 2. Find the volume of the solid formed by revolving the region about y equals x minus x cubed and the x-axis. So the x-axis is here. I'm sorry, the x-axis is one of the bounds. It's going to be revolving about the y-axis. So here's our y-axis. We're going to be revolving around the vertical line, which means our representative rectangle is also going to be vertical. And think top minus bottom, everything will be in terms of x. So here, distance from our axis to the point where this rectangle is, we can call this x. That's the shell radius. The shell height is given by this equation here. Any point on this graph represents potential height for our shell. And then 2 pi in front, and then our bounded region extends from x of 0 to x equals 1. So then 2 pi integral 0 to 1 x times x minus x cubed. We're just following this formula here. Distribute the x through. Evaluate using power rule. X squared becomes x cubed over 3. X to the 4th becomes x to the 5th over 5. And then we plug in the upper bound, subtract the lower bound. The 0 will give us 0, so I just left that out. Distribute the 2 pi through, and we get 2 pi times 2 over 15, which gives us 4 pi over 15. Example 3, find the volume of a solid formed by revolving about the region bounded by x equals e to the negative y squared and the y-axis about the x-axis. So now we're revolving around a horizontal line, which means that our representative rectangle is also going to be horizontal. Think right minus left, everything has to be in terms of y. So now our representative radius is given by y from 0 to this value is distance y. And then any point on this graph here is the representative height, but in terms of y, so we have the equation e to the negative y squared. And then our bounds are going from the lowest y value to the highest y value, so from 0 to 1 of our shaded region. Now with this, we can't go through power rule. However, we can go through U-substitution. If we let the u value be negative y squared, its derivative will nicely match and cancel out with this remaining y, which will allow us to use the rule for e to the u. So we go through U substitution. U is equal to negative y squared. Du over dy is negative 2y. We solve for dy, which is du over negative 2y. The y's cancel out. Negative 2 will cancel out with the 2 from the 2 pi. And now we can evaluate. Integral of e to the u will remain e to the u. Replace the u back in terms of our original variable, y squared. Plug in upper and lower bound, and we get e to the negative 1 minus e to the 0. E to the negative 1 is 1 over e. E to the 0 is 1. Distribute the negative pi through, and we get negative pi over e plus pi. Example 4. All right, so now we have volume solid revolving around, bounded by the graph y equals x cubed plus x plus 1. So here's our x cubed plus x plus 1. Y is equal to 1 is here. And x equals 1 is here. So now we have this little kind of a triangle looking shape here. That's our shaded region. But now we're revolving about the line x equals 2. So x equals 2 is our axis of revolution. Vertical axis means that for shell method, we're also going to do a representative rectangle using vertical rectangles. Now, the thing that's different here is that our representative radius is no longer going to be x, because if we do x, then that's distance from here to here, and that's not the distance from the representative rectangle to the axis. Our axis is over here. So the distance from here to this representative rectangle, we can call this distance x, but if we want to find the distance from here to here, then that's going to be a distance of 2 minus x. All right. This distance is 2, so 2 minus x will give us this remaining region, 2 minus x. So 2 minus x is our representative shell radius given here. Our shell height is in terms of x because we have vertical rectangles. So just like with this method, we do everything in terms of x. So here x cubed, y is equal to x cubed plus x, so we replace y with x cubed plus x. Our bounds are from the furthest left to the furthest right of our shaded region, so from 0 to 1. And here we can just go through, we can actually go through power rule, but first we need to distribute. So distribute to get rid of each of the parentheses. No like terms to combine. We can now go through power rule for each of the terms. Plug in our upper and lower bound. The lower bound in this case will just reduce to be 0. So just the upper bound will result in values. And then we distribute the 2 pi through. 2 pi times 29 over 30 gives us 29 pi over 15.